Okay, students, so what we're going to look at here is Lesson 10-2, Simplifying Radical Expressions. Now, of course, we looked at radical expressions back in Chapter 7, as well as exponents. And so here, what we're going to do, and this will be key for multiple concepts that you'll be dealing with when you get to Algebra 2, especially. So in simplifying radical expressions, let's just take a look at our objective for today. Okay, our objective: simplify radical expressions by using product property of square roots and quotient property of square roots. Okay, so we're going to take a look at that. How do we go about, and specifically, how do we go about simplifying radical expressions? And the way that we're going to do that, as you'll notice in today's lesson, is we're going to take a radical expression, which what I mean by that, okay, radical expression is whenever we have the radical over a number. And specifically today, we're going to look at that number is not going to be a perfect square. So how do we go about simplifying radicals which are not perfect squares? All right, so then, okay, also, we're going to look at making sure when they are in simplest form. Okay, radicand, okay, so that's the number, as we've talked about in the past. That's the number that's underneath the radical sign. Okay, a radicand is in simplest form when no radicands have perfect square factors other than 1, no radicands contain fractions, and no radicals appear in the denominator of a fraction. Now, what we're going to look at in this particular lesson, we're specifically going to focus in on number 1. Okay, but then on 2 and 3, that will be in the next lesson. Okay, so what is product property of square roots? Okay, so for example, we have the square root of a times b, but we can separate that out, and we'll look at that today. Okay, we have the square root of a times the square root of b. Now let's say we use numbers. Well, if we have 4 times 9, that is equal or equivalent to the square root of 4 times the square root of 9. Okay? All right. So let's take a look at our first example. Okay, what we're going to do here, we're going to simplify this radical. So for example, if I have the square root of 80, well, we know that 80 is not a perfect square. We've talked about perfect squares, of course, in the past. Okay, perfect squares, for example, would be like 4, 9, 16, 25, 36, 49, and so on. Okay? Now, 81 is a perfect square, but this is not 81. This is 80. So what we're going to do here, we are going to simplify this radical. The way that we do that, there's actually a couple different ways you can do this. Now, one method is to write out the prime factorization. Okay? So to write out the prime factorization, we find a couple of factors of 80. So for example, like 8 times 10, and then we continue to simplify that. Okay? But the way that I teach it, the way that you're going to see me go through this process is this. Okay, I'm going to look at this number 80. And remember what we looked at on the previous slide? On the previous slide, we had two numbers, for example. So if we had underneath the radical sign, if we had 4 times 9, we can rewrite that as the square root of 4 times the square root of 9. Okay? So we can do that here as well with the number 80. Now I want to find two factors. And specifically what I really want to do, I want to find a perfect square factor of 80. Okay? Now, a perfect square factor of 80, okay, we could think, well, let's just think through it. If I just took two factors, let's say 8 and 10, okay, 8 times 10. Of course, 8 times 10 is going to equal 80, but neither one of those numbers is a perfect square, okay? Now, 8 is a perfect cube, but it's not a perfect square, and we're looking for perfect squares. Well, okay, let's think through our numbers here, okay? Well, would 4, would that be a factor of 80? Yes. Okay, it would. We can multiply that times 20, but then we're still going to be left with, now if I did that, it's okay, you can do that. So if I go like square root of 4 times square root of 20, now of course square root of 4, that is a perfect square. That's great. So now we can simplify that. But 20, does that still have a perfect square? Yes. 4 times 5, right? Now, if you notice that, if you don't find the greatest perfect square factor right off the bat, that's perfectly fine. It's okay. Just check your numbers. Okay, this one I can simplify. I see it with 20, I've got 4 is a perfect square factor, so I can simplify that. So with that, I'm going to simplify, and I would say, well, now I've got 2 times square root of 4 times square root of 5. So now all I'm going to do, I'm going to simplify the 4. We get 2. 2 times 2 is 4. Okay? All right, so your simplified answer would be 4 in the square root of 5. Now, I'm going to show you, okay, the easiest way to do this is when you find the biggest perfect square factor. So 4 we know is a factor. 9 is not. What about 16? Okay, 16 is, because 16 times 5 does equal 80. So here we have the square root of 16 times square root of 5. Square root of 16, which is 4, times square root of 5. Now, square root of 5 is not a perfect square. And remember, what's our objective? Remember step number 1. Okay, we want to remove all the perfect squares underneath the radical sign. Okay, so that's what we've done. We have removed all those perfect squares underneath the radical sign, and we are left with 4 in the square root of 5. And that is in simplest form. Okay, that's what we're doing here. Okay, even though we do have a radical left, there is no perfect squares underneath, so we are good. Okay, all right, so let's take a look at another example here. Let's say that we have the square root of 54. All right, so this one, yeah, pretty simple because we have 2 factors thinking to our multiplication tables. Okay, with our multiplication tables, we know that we have 9 and 6. Okay, so we can start off, we could go through all of our perfect squares. We have 4. Of course, 9 is, what about 16? Okay, is 16. No, it is not. Okay, we go 16 times 3. That's about as close as we can get, so it falls short. So 9 is going to be the biggest one. So we're going to say square root of 9 times square root of 6. Now, once again, square root of 9, that is a perfect square. We can simplify that. 6. Now, 6, even though it's an even number this time, we have no perfect square factors of 6. Okay, we got 6 times 1. We have 2 times 3. None of those are perfect squares. Okay, so this is actually in simplest form. Okay, we have removed all the perfect square factors underneath the radical sign, so we have simplified it. Okay, so let's take a look. Now, if we have an expression in which we start off and we actually have 2 radicals, okay, we've got the square root of 2 times the square root of 14. So what we're going to do, we're going to start off this time, and we are going to multiply those 2 together. We have 2 separate radicals. We're going to start off and multiply first. Okay. Now we're kind of back to square 1 here. Okay, we talked about on the first slide. Now we have the square root of 28. So let's think through. Okay, do we have any perfect square factors of 28? Well, this is another one in which we're going to have, going back to the good old multiplication tables, right? And then we simplify square root of 4 for 2. Oops. And the square root of 7. And that is in simplest form. Okay, no perfect squares underneath the radical sign. Okay. All right, let's do one more. Okay, this time we have square root of 5 times square root of 10. Multiply those together, we get square root of 50. Okay, what's our biggest perfect square factor for 50? 25. Okay, 2, that is the square root of 2, that is in simplest form. So we have 5 and the square root of 2. Okay, so this time we are going to look at an example. Now we have variables included, okay? Now, what we've been doing up to this point, we've had numbers, and we've had to remove all the perfect square factors of the numbers, and that's still going to be true. Okay, we're going to remove all those perfect square factors of 90 in this case. But what happens when we have variables? Well, thinking back to chapter 7, whenever we looked at variables, okay, with a variable, anytime a variable is a perfect square, well, that means that your exponent will be an even numbered exponent. Okay, so for example, y to the fourth here, that is a perfect square. Okay, so what we have to do here with our variables, remember, we can create products of radicals. So here we could do this. We could say, well, I got the square root of 90 times x squared times x. Now, why did I do that? Well, remember what I just said. Okay, with your variables, okay, variables must have an even numbered exponent in order to be a perfect square. Okay, and we're trying to eliminate all the perfect square factors underneath the radical sign. So, is x squared times x, is that equivalent to x cubed? Yes. Okay, multiply those two together, because remember what our rules were. Okay, anytime I multiply with the same base, what do you do with the exponents? Add them together. Okay, so that's why x squared times x is equal to x cubed. Okay, so y to the fourth is good. It's an even numbered exponent, so that's already a perfect square. We don't have to rewrite that one. But what about z to the fifth? Now, once again, thinking I have to have an even numbered exponent, and really, you have to get the highest even numbered exponent. So it's going to be z to the fourth times z. Okay, so that's an equivalent expression to z to the fifth. Now what we're going to do, we're going to go through and we're going to simplify. Okay, looking at the number 90. Well, for 90, what is the biggest or highest perfect square factor of 90? It's 9. Okay, so we know that square root of 9 times square root of 10. Then we look at, of course, our variables. We have square root of x squared times square root of x times square root of y to the fourth times z to the fourth times z. So going through here, I'm going to do the square root of 9, which is 3. Okay, so I've simplified that one. X squared, that's going to be equal to, okay, x. But then we're going to look at the y to the fourth. Okay, y to the fourth, that's going to be y squared. Z to the fourth is z squared. Now the rest of those underneath the radical sign, alright, so none of those are perfect squares. We have no perfect square factors, so they stay underneath the radical sign. Okay. So that would be your simplified answer. Once again, you're just trying to remove all the perfect square factors. Okay, so we will do one more of these. We have square root of 56, x, y to the 10th, z to the 5th. Okay, so on this one, we're going to start off, look at the number 56. So for 56, think through, okay, well, what are perfect square factors of 56? Well, we start with 4. Okay, is 4 a factor of 56? Actually, it is. Okay, 4 goes into 56 14 times, and that actually is going to be the highest perfect square factor. Okay, so we go 4 times the square root of 14. Then we have times the square root of x. Okay, we can't rewrite that. Okay, that's just x to the first. Then we have y to the 10th. That is already a perfect square because we have an even numbered exponent. But z we have to rewrite. Okay, all right, so let's simplify. Square root of 4 is 2. And 14, we have no perfect square factors. X, no perfect square factors. Y to the 10th becomes y to the 5th. Now, this is a thing. Pay attention on this one. Anytime you go from an even numbered, go from an even numbered exponent to an odd numbered exponent, you must put absolute value signs around it. Okay, so once again, even numbered exponent to an odd numbered exponent. When you simplify that, absolute value signs. Okay, all right. Then we're going to take that last one here, z to the fourth simplify that. That's even to even, so we don't have to put absolute value signs around it.